Welcome back to Grade 7 Math. This is lesson number 12.1, Variables and Expressions. Okay, just going to start off just by reviewing um, some learning goals and success criteria. We have completed the first half of our patterning and algebra unit. Wow, did we do that quickly? That was all in favor of getting to the second and the main half of our unit, which is, of course, algebra. Uh, but here are the main learning goals we reached through Chapter 6. Number 1, we learned how to find patterns in a series of numbers or shapes and describe the patterns which we found. We also learned how to show linear relationships through tables of values and graphs. And then some success criteria here. Yeah, 2 points. One, we did this just recently. We created tables of values and we showed the information from a table of values on a graph. So we did that quite well in only about a week's time. Okay, moving onwards now into chapter 12. Here are the learning goals which we need to reach for the algebra portion of our unit. We need to learn how to write algebraic expressions and equations, and we also need to learn how to solve equations using these methods: inspection and guess and check. And on the next page, let's look at the success criteria which we need in order to reach these two goals here. Okay, we've got 6. Number 1, we need to be able to turn phrases into algebraic expressions and vice versa. So if we see something like 2 more than the number, in algebraic terms it means n plus 2. We need to make algebraic expressions to show a pattern. We've actually done some work with that already. Uh, so if you want, if your memory is shaky, go back and watch our videos from chapter 6 and you'll see where we actually got into working with making algebraic expressions. We're going to need to be able to solve algebraic expressions by replacing the variable. That's the letter with the number. And we did that a little bit too near the end of last week. So go back and take a look at the video for lesson number 6.4. We are going to solve equations by using diagrams. We'll be doing a little bit of that in this and the next couple of lessons. We are going to solve equations by guessing and checking. And then in order to make this a practical unit, we are going to solve real-life problems that involve using an algebraic expression and by making a table of values or a graph. So lots going on in this unit. Today's lesson is all about using variables and writing algebraic expressions. We better begin by finding out what a variable and an algebraic expression are. Okay, I'm going to test you guys on this. Okay, I'm going to tell you right now. A blank is used to represent an unknown amount. Actually, we should know that from last week's lessons. A variable is used to represent an unknown amount. And blank is a mathematical statement that describes the situation. It has a mix of letters and numbers. That would be an algebraic expression. Here's an example of a variable. Well, up here we said it's used to represent an unknown amount. We've talked about how you use letters to represent unknown amounts. So the letter B is an example of a variable. And of course, an example of an algebraic expression, one that uses letters and numbers, z plus 4. Okay, so we're going to review this at the start of tomorrow's class. So take a moment to study this over. Now, let's start practicing the usage of variables and writing of algebraic expressions. For these first activities, we are going to use cups to represent the variables, that's the letters, and counters to represent the numbers. Okay, so again, the cup represents a variable, an unknown amount. The counters represent a known amount. So what would this diagram represent? Well, let me set up my pen here. And we have said that you can use any letter as a variable. Well, N is a pretty popular letter, so we'll say N because we have only one cup. Okay, plus means plus. How many counters? We have 4. So N plus 4. Now as I did this, I was just thinking, N is perfectly fine. But for these next examples, why don't we use the letter C, because the word cup starts with the letter C. Okay, I'm going to do the diagram on top, and you're going to try the diagram at home. Okay, and you can have algebraic expressions that have only variables. Okay, they don't have to have known amounts in them. So let's take a look. We've got 2 cups. So we're going to say 2 and cup starts with the letter C, so we'll say 2C. 2C. There we go. So put the video on pause, try this one at home, and we'll go over it tomorrow. Okay. Now, this part we'll need to go over in class tomorrow. Okay, I'm looking at bringing in cups and counters for you to use so that you can model these equations, or sorry, not equations, expressions. I've got to be very careful about that. These are expressions. There's a reason why they're called expressions. Okay? But if you want, what you can do at home is you can put this on pause, get a piece of paper, and just try. Well, you know what? Let me do the first one here for you. Okay? So we've got k plus 4. So I'm just going to draw, hard for me to draw a cup here. Okay, this is my cup here. Okay, so I've got 1 cup. I'm adding 4 counters. Okay, this is what I mean. So try this at home. Okay, you may not have the cups and the counters. If you have cups and counters, you can certainly try it out, like we did on the previous slide. Otherwise, just do a diagram like this one here, and then we'll go over it tomorrow. Okay, I'm anticipating that we're doing pretty well with this. So now let's try some equations without using diagrams. Okay, we can write algebraic expressions to represent different situations. So for example, a number plus 5, we can say n plus 5. Okay, 4 times the width. we can write that a couple of ways. We could say 4 times W, or, so we don't have confusion with the time sign here, we can just say 4W. Okay, now these I want you to try out at home. Double a number, 10 centimeters shorter than you, triple the height increased by 4. So put the video on pause, try these out, and we'll take it up tomorrow. Now, you might be wondering, can we ever solve and equate an algebraic expression? Well, we can, but first we need to know what the variable equals. So here's an example. Okay, t plus 4, and then we're told that t equals 3. So what you do is you substitute the t with a 3. Ooh, I'm a poet. Anyways, so take out the t, put in a 3, okay? And of course, 3 plus 4, if my pen will agree with me, okay, 3 plus 4 equals 7. Okay, I'm going to try the first one, and you're going to try the other two at home. So we've got r minus 6, r equals 13. So change that r to a 13. So 13, take away 6 equals 7. Okay? Just a hint, a reminder, when you don't see a sign in between the number and the letter, it means multiply. Okay? So put the video on pause, try these two at home. Whew. This is a long lesson, and we're finally reaching the end, except try to remember a formula. There's E equals mc squared, c squared equals a squared plus b squared. No. All right, here it is. Haha. There is your equation. Okay, so after we go through this video and tomorrow's class, I'm giving you a bunch of problems to try out. They're all relatively quick, but practice makes perfect, as Mr. Albert Einstein would tell you. So until tomorrow's class, this concludes today's video.